Give me a second. Did you already start recording?
It's starting right now. Okay. Okay.
Oh, bro, I don't think it's recording yet.
Yeah, I have it. I have it here recording on my. I have an app for that. Okay.
Oh, okay. So like you're recording it in your phone?
No, on my laptop. I'm recording
Oh,
it on my laptop. Okay.
all right.
So let's start. This is CNT 4165 Network Protocol for IoT. This is topic presentation for Team One, and the topic is Advanced LPWAN Technology by Marcel Castro and Nurain Chaudhuri. Okay. So what are low power wide area networks? Low power wide area networks, LPWANs for short, describe a class of radio technologies that are used for long distance wireless communications, whereas other wireless technologies such as Wi-Fi and Bluetooth transfer big data packets over short distance. LPWANs are used to send much less information over bigger footprints. There are two broad categories under which LPWAN protocols are grouped: cellular and non-cellular. Cellular LPWANs, which include LTE-M and NB-IoT, use licensed frequencies. Non-cellular LPWANs, such as Sigfox and LoRa, they use unlicensed ISM radio bands. The history of LP1s. The origins of LP1s can be traced back to the late 1980s when Ademco built a low data network to monitor alarm panels. Around the same time, Motorola launched a low-speed wide area network (RDIS) for certain sales automations and transaction tracking processes. In the 1990s, 2G was born as cellular carriers began to transmit data alongside voice over long distance. Over time, internet demand skyrocketed, pushing companies to include connectivity capabilities in more and more devices. With this trend came the need for lower cost, lower power wireless communication solutions. In 2009, the French company Sigfox built the first modern LP1 which could integrate applications in real time more effectively than past forms of radio technology. Sigfox LP1 is a proprietary and used throughout dozens of countries today. 3 years later, Semtech launched the LoRa protocol, which operates in various unlicensed bands depending on the country where it is located. With LoRa, developers can deploy their own wide area networks rather than use existing infrastructure. For cases where it is desirable to connect to an existing network, some public LoRaWAN providers have emerged, including CNT, the Things Network, and MachineQ. Today, there are a number of companies deploying LP1s for various applications, many of which participate in the LoRa Alliance. Created in March 2015, the LoRa Alliance is a non-profit association consisting of more than 500 members organizations that aim to promote the success of LP1 protocols worldwide. So let's ask ourselves now, why are low power wide area networks so useful for the IoT sensor? Low-power wide-area networks transfer information at a much lower bitrate compared to other wireless communication technologies. They consume less power from connected wireless sensors compared to other radio technologies such as Wi-Fi or Bluetooth. As a result, LP1s enable sensors can transmit event-based data packets for up to 10 years or more on a single battery. Comparatively, today's best smartphones can last around 1 or 2 days. LP1s also have a very wide coverage areas, enabling wireless sensors to send digital information over long distances. Outdoor base stations and towers typically have from around 1 to 30 kilometers range depending on the location on the sensor and other environmental conditions. They also require fewer access points to achieve longer distances. Third, LP1s are far less costly to access and deploy. Because wireless sensors transfer very small amounts of data, associated hardware, components, and infrastructure are much more simple and thus inexpensive. Okay. These are the leading non-cellular LPWAN technologies available today. Sigfox and LoRa are the most widely used non-cellular protocols today. Sigfox uses ultra-narrowband modulation, a highly efficient method for transmitting information to send very small data loads up to 12 bytes of data. Sigfox has installed base stations all across the country, creating wide LPWAN coverage for IoT devices in most major US cities. Sigfox is typically best suited for simple sensor devices that only need to communicate a small number of messages per day, such as thresholds, alerts, security alarms, emergency event monitoring, etc. LoRa, short for long range, uses a shear spread spectrum modulation scheme to transfer digital information over long distances. LoRaWAN sits on top of LoRa and is an openly available media access control layer specification. The scheme is resistant to multipath fading and can transfer bigger data loads than Sigfox. LoRaWAN also uses more bandwidth due to its modulation scheme versus Sigfox ultra-narrowband technology and therefore can support a larger number of devices transmitting at the same time. So right here what we have is a comparison in a table of with certain parameters between LPWANs and LoRaWAN, such as range. For LP1 it delivers a long range bigger than 80 kilometers line of sight, bigger than 10 kilometers suburban, and bigger than 5 kilometers in urban areas. For LoRaWAN we can reach up to 30 kilometers in flat areas without any interruptions. The market value for LP1 market size is expected to grow beyond 20 billion by 2027. LoRaWAN market size is projected to reach 5,558 million by 2026. The network operators for LP1 is handled by LoRa, Sigfox, NB-IoT, and LTE-M, and for LoRaWAN's autonomous networks, one or more per country. The payload length for LP1 delivers a payload of not more than 12 bytes, and for LoRaWAN has no restrictions. Payload can be easily exceeded by 100 bytes. Internal networks roaming for LP1 enables subscription to LTE-M or NB-IoT networks. For LoRaWAN, currently limited but improving. So we have here some parameters and we can see that they have differences, but each one of them is good for it depends on the what specific uh, kind of environment you want to deploy these technologies. So here we have LP1s, the advantages and limitations. So advantages for LP1: low number of gateways, free radio spectrum, low power usage. Limitations: it's unfit for the frequent data transfer applications, low data rates, high risk of clog the network and hamper data transmission, unsuitable for low latency applications. This is LoRaWAN and NB-IoT. Advantages and limitations of LoRaWAN. Advantages are longer range, low power, equals more battery, simple architecture, better compared to Sigfox, fast deployment. Limitations of LoRaWAN, not ideal for large data payloads, unlicensed radio network, and less secure. How are LP1s related to the Internet of Things? With the Internet of Things space set to boom, LP1s will become critically important. Across many different industries and spaces, thousands of devices will work together to automate functionality, reduce operational costs, and reach new heights of productivity. We need wireless networks that can easily transmit data over long distances without consuming much power. Additionally, companies that will deploy IoT devices need a cost-effective solution that will enable them to simultaneously connect many sensors to the internet. Otherwise, many exciting IoT applications won't actually be feasible. Now the application for IoT of the LP1 technologies for smart cities, in industry, in agriculture and farming, smart healthcare, environmental monitoring, asset tracking and logistics, all of these applications. exploring the spectrum of LPWAN technologies for IoT. LoRa technology, bridging distances with low power. The description of LoRa technology, a spread spectrum modulation technique derived from shear spread spectrum technology, offering long-range communication and low power consumption. What are the strengths? Long range and deep penetration, excellent for rural and indoor coverage. Low power consumption, ideal for battery-operated devices. Flexible deployment, support both private and public networks, large ecosystem, strong support for the LoRa Alliance, and a wide variety of available hardware. Weaknesses, data rate limitations, not suited for applications requiring high data throughput, interference is unlicensed spectrum, interference in unlicensed spectrum susceptible to interference from other devices. The opportunities are the smart cities and IoT expansion, growing demand for smart utilities, asset tracking, and environmental monitoring. Innovation in IoT devices, development of new applications and devices leveraging LoRa's low power consumption. Now the NB-IoT, the cellular path to IoT scalability. The description for NB-IoT is a standards-based LPWAN technology developed to enable a wide range of cellular devices and services. The strengths, high scalability, supports a large number of connections per cell, deep indoor coverage, superior building penetration, low power consumption comparable to LoRa, and standardized technology backed by 3GPP, ensuring global compatibility. The weaknesses are the higher deployment costs, requires cellular infrastructure, limited in mobility support, not ideal for applications requiring device mobility, and the opportunities, utility and smart city projects, large-scale projects requiring deep penetration and reliability. Integration with 5G, part of the broader 5G rollout, offering future proofing. Oh, now it's your turn, Noreen.
All right, Marcel, could you like stop sharing the screen so that I can share my screen?
Okay. Oh, wait. Stop sharing. Okay.
Also, you have to like enable the screen sharing to me.
It's done.
All right, so in this slide, we will be going over the integration of LPWAN with 5G networks. This combination promises improved connectivity with higher data rates and low power consumption. Additionally, advancements in battery technology aim to extend the lifespan of LPWAN enabled devices, potentially allowing them to operate for decades without needing a battery replacement. Enhanced security protocols are being developed to safeguard data transmission, addressing the increasing need for robust security measures. Lastly, the applications of LP1 are expanding across various sectors, from smart grid, agriculture, and environmental monitoring to industrial automation and healthcare. In this slide, we will be going over common LP1 limitations and challenges. While LP1 technology offers many benefits, it is not without its limitations and challenges. Coverage issues can occur in remote or densely populated areas, making it difficult to maintain consistent connectivity. Additionally, LP1 signals may face interference from other wireless technologies, particularly in urban environments. Security concerns are also significant as LP1 networks can be vulnerable to cyber threats. Therefore, robust security measures are essential to protect data integrity and privacy. In this slide, we will be going over applications of LP1. LP1 technologies are revolutionizing various industries with their diverse applications. In smart agriculture, LP1 enables precision farming by monitoring soil moisture, weather conditions, and crop health. Smart cities benefit from efficient lighting, waste collection, and traffic monitoring, enhancing public safety and city planning. In industrial automation, LPWAN tracks equipment performance and streamlines supply chain operations. Environmental monitoring and smart healthcare also leverage LPWAN for air quality monitoring and remote patient health data collection. Um, Future potential of LP1 technology. The future potential of LP1 technology is immense. We anticipate increased adoption in emerging markets and new sectors such as smart homes and autonomous vehicles. Integrating LP1 with AI, machine learning, and big data analytics will enhance IoT applications, leading to more efficient decision making. Improved network infrastructure and advances in protocols will support wider adoption. Cost reductions and sustainability initiatives will make LPWAN solutions more accessible and environmental friendly, promoting global connectivity. In the next slide, we will be going over some of the key players who are working in this industry. Uh, so one key player would be Semtech Corporation, who leads in developing LoRa technology, providing both hardware and software solutions for IoT. Then there's Sigfox, which is also known for ultra narrowband technology and offers a global network for IoT connectivity. The LoRa Alliance, on the other hand, promotes the adoption of LoRaWAN and fosters collaboration among companies. NB-IoT, developed by 3GPP, is supported by major telecom operators for cellular IoT connectivity. Lastly, there's Senet, which focuses on building and managing public and private LoRaWAN networks. Um, some of the benefits of LP1 technology would be LP1 technology provides several significant benefits. It supports long range communication, making it ideal for rural and remote areas. Devices using LP1 operate on lower power, reducing the need for frequent battery replacements. The technology is cost effective to deploy and maintain compared to other wireless communication options. LPWAN is scalable, supporting a large number of devices for massive IoT deployments. Additionally, it is robust and reliable, designed to function effectively even in challenging environments. Um, Comparing LP1 technologies. So let's compare some of the key LP1 technologies. Um, for example, LoRa offers long range, low power, and flexible deployment, but has limited data rates and potential interference in unlicensed bands. Sigfox provides wide coverage and is cost effective for simple use cases, but has a limited data capacity. NB-IoT offers high scalability and deep indoor coverage, but comes with higher deployment costs and limited mobility support. Weightless is an open standard adaptable to various needs, supporting both narrowband and broadband, but it faces adoption and compatibility challenges. Uh, so this brings us to the conclusion to our presentation. Uh, LP1 technology represents a significant advancement in wireless communication, offering long-range, low-power, and cost-effective solutions for IoT. Despite challenges like limited data rates and security concerns, the future of LP1 looks promising with continuous improvements and integration with emerging technologies such as the 5G. As we move forward, LPWAN will play a crucial role in the growth and development of Internet of Things, enabling smarter and more connected environments. Thank you for your attention, and we are happy to answer any questions you might.
Okay, man.